Hi, my name is Emma Comstock-Reed. I am an 8th grade math teacher, and this week's video is designed to support Teach Hub's Week 27 series of lessons based on illustrative math curriculum. And our unit right now is exponents and scientific notation. Specifically this week, students are going to work on some operations and calculations with powers of 10 and learn the definition of scientific notation and how to express very large and very small numbers using scientific notation. So in my student-facing video for this lesson, I used a routine called Capturing Quantities, which comes from this website, fosteringmathpractices.com. There's also a book of these routines called Routines for Reasoning. I'll just show you the website quickly now. So on the website, you can see that's their book, and the routines for reasoning are these, and each of them is based on a different math practice. The one that I used for this lesson is called Capturing Quantities, and you can see resources related to it if you just click on that section. You can register and create a free educator account, and all you need is any email address. The reason why I use routines like this one a lot is because it's a way for us to develop mathematical habits of mind and proficiency in the math practices. Now, for scientific notation word problems, I find that it's much more important to focus on those math habits of mind than it is to focus on the calculations. Really what gets in students' way with those problems is being able to picture how the quantities are related to each other and slow down enough to really ask themselves what relationships are in the problem, what information they need, etc. So capturing quantities is all about students understanding what are the quantities counting or measuring in a problem, and how are those quantities related to one another. So let's look at day 23 for an example of what I would suggest for when you introduce calculations with powers of 10. So now I'm in the slide deck for day 23, and I'm in the teacher-facing section for guidance for assessment during instruction. And this is a great slide to look at when you're planning, just to think about, well, during the lesson, what is my biggest goal? Like, what am I looking for? And these are the essential understandings that we're looking for in day 23. And I especially want to talk about this first bullet. To set up these problems, it's important to think about the information you need as well as what you will do with that information. For example, on slide B, you need to take the mass of the moon and divide that by the mass of a single meter stick to determine how many meter sticks would equal the mass of the moon. From there, we can solve by representing the division in fraction form and using exponent rules to calculate the quotient. So in my experience, when students have to deal with scientific notation word problems, the biggest struggle really comes from understanding what the word problem is telling them and understanding how the quantities are related more than the numbers in scientific notation themselves. So we can anticipate that there are a lot of students in our classrooms who are coming in with some confusion about multiplication, division, subtraction, and addition, and how they show up in word problems. They may have had experiences where teachers taught keywords, which didn't serve them well as the problems got more complicated. They may be coming in with no way of visualizing multiplication and division. They might also have the misconception that you can only use one operation, and they might be overwhelmed trying to figure out what that operation is and just choose something randomly, operate with the numbers without really slowing down and thinking through the problem. So that's why I used capturing quantities for this lesson in my video. And that's one way to address this because it walks students through how to diagram to show relationships. So the capturing quantities routine, you can read more about it on the website. But part of that routine asks students to diagram the quantities and relationships. So I'm just going to quickly show some bar modeling examples now. So there are many different ways that you can help students learn how to visualize problems. But I'm just going to quickly show one example that comes up a lot for me in this scientific notation unit, which is how many times versus how many more, or how much more. And just one sec. And this is really challenging for students in terms of figuring out whether it's more logical to multiply, divide, subtract, etc. So kids who you learned keywords often will see times, how many times more, and think that they need to multiply because they learned that keyword means multiplication. And then the other confusion that comes up here is division versus subtraction. So when I talk to students about these different question stems, I use an example, and I'll just tell it to you now. Let's say in this fictional world, I am 6 feet tall, and I start with this kind of example before I show bar modeling. I am 6 feet tall, and my dog, this is my dog, is 2 feet tall. I'm 6 feet tall, and my dog is 2 feet tall. How many times taller am I? How much taller am I? And I would show how many times taller, like this. And I would show how much taller, like this. So what I'm emphasizing is that how many times is asking us how many of Al's height can I fit into my height. And I lost my units here, which is not something I would recommend. I would still show them. And then when I'm saying how much taller, I'm saying, or how many more feet, right? I'm looking for the difference. And depending on which question we're answering, our units of our answer are going to be different, right? So this is 3 times taller, and this is 4 feet taller. And that's another recommendation I would have for when students are working on scientific notation word problems is say, what will our answer sound like? So we can ask, how could we represent the relationship? We could ask, what will our answer look like? Another strategy that I would suggest is to remove the numbers entirely. And I'm going to go back to day 23 to show an example of that. When you have students look at word problems like this, and I'm moving ahead to slide B, the tricky thing here is knowing what quantities we're using and how to use them based on the question, not as much the numbers in scientific notation. And in fact, the numbers can be a distraction that prevent students from deeply thinking about how the numbers are related to one another. So my suggestion would be to use routines like capturing quantities, but also to do some numberless word problems here. So what you could also do with this type of problem is just block out the numbers and leave the units. I'll show an example of that now. And then that can help students see, okay, well, based on this question, I need bullets about mass. And then without the numbers here, they can say, okay, what I will need to do is divide this by this, right? Divide the mass of the moon by the mass of 1 meter stick. And if students can say that that's what they need to do without even including any numbers at all, they're already more than halfway there. Like, that's really the lift we want to focus on here. How can we use visualization, reading carefully, paying attention to units, so that when students problem solve, they problem solve logically, I hope that thinking through strategies to help students problem solve with word problems for scientific notation was helpful for you. I'm going to list some ideas on this slide if you want to pause, and have a great day.